Hello YouTube! Here's my Cherry MX1000 mechanical keyboard. Yes, back in the day they already had mechanical key switches. This keyboard started being manufactured in 1981, though nowadays they are very modern. They also have been used, back in the day when this keyboard came out. And yeah, it's a very old keyboard, and it even used this AT connector, which has been used before the PS2 connectors, which a lot of current mainboards still have. And yeah, that's why I built this signal converter to USB. It's using a Sane Smart Arduino Leonardo clone, and I used these cable end sleeve thingies to connect the pins from the AT connector to my Arduino, because I didn't want to cut open the cable or solder to my keyboard's board. So I just used these pins, pulled off the plastic, soldered my wire into it, and put it over the pin of the connector. And yeah, it actually works. So I move to my monitor, and now you can see my monitor, and I can type some text, also with capital letters. So I can also use combinations like Command A to select everything. Yeah, works very well. And another thing that a lot of the similar implementations for signal converters from the old PS2 or AT connectors to the USB HID protocol didn't use is the LEDs here, because the computer actually needs to send a signal to the keyboard that tells it to turn on its LEDs. So I press the caps lock, which doesn't do it because I have remapped the caps lock to command, because this keyboard doesn't have the command or Windows key. And now I use this key, the scroll lock, as a caps lock, and you can see it turns on the caps lock light, and also the num lock works. Yeah, I mean, scroll lock, nobody even knows what it does. Actually, it allows to use the arrow keys without moving the cursor and just moving the window, but nowadays we have mice, so we don't need it. Yeah, and now I'm going to show you how I programmed it and how the protocols work. See you in a bit. Here I'm back. You can now see my computer monitor, or what it displays at the moment. And yeah, I can also show you my keyboard working in. So here's like the keyboard view. And this is my usual keyboard. And I didn't want to do that. No. I can press all bunch of keys and it works. And now I have my old keyboard. And what's interesting about it is that I cannot press all the keys together. I mean, this keyboard actually was marketed as a N-key rollover keyboard, which means that I can, in theory, press all the keys at the same time, which I can do with this keyboard. But yeah, most keys can be pressed together. I mean, over the PS2 protocol, the USB protocol, or the basic USB protocol at least does not support it. But for example, if I want to press A, S, and now I cannot press D. I can press F, but not D. And this is not a mistake in my programming, but it actually, the keyboard doesn't appear to send these commands, which we can see, because now I'm going to talk about how the PS2 commands work. So the basic protocol consists of the keyboard sending commands to the host. Also, the host can send commands to the keyboard, but now we're going to focus on this direction here. And this is the way we get the scan codes for the keys. So here you can see the scan codes. For example, A has the scan code 1C, and we also have some extended scan codes like insert. This is preceded with an E0. Or we also have crazy scan codes like for pause. E1 1477 E1 F0 14 F077. I have no idea why they made that complicated. And it also doesn't send, if it's released, normal keys like A send their scan code preceded by an F0 if they are released. Here you can see again the connector, which probably couldn't see too well in the video. My keyboard has this connector. We have a clock line, data line, line that isn't used, ground line, and 5 volts. And yeah, PS2 uses the same pin assignments on a different connector. And yeah, this is what actually goes on there. So we have the clock and data. When I don't press any keys on my keyboard, it also is in an idle high state, so I don't need to read any data there. But if I press a key and it wants to send something, it starts to generate a clock signal, and on its first falling edge there isn't any data. Second one, there starts to be the 8 bits for the byte, and then we have a parity bit, which is an odd parity bit. So if we have the total number of bits that are set will always be odd. So if I have 3 bits set, then the parity bit will be 0, so that I have 3 bits in total that are set, which is an odd number. Yeah, so yeah, these scan codes are sent to my keyboard, and so I are sent from my keyboard to my PC, and therefore I wrote this PS2 scan code application, which runs on my Arduino and just outputs all these scan codes via serial connection to my computer. Now I will upload it quickly, and then I can show you what the scan codes look like. You can see I press the A key and 1C, which is correct, is outputted to the serial terminal, and as I release it, an F0 is outputted followed by a 1C. If you remember, F0 means that the key is released. If I hold it, it just sends 1C all the time. Now, for example, here you can see that I press A, S, this works, but D doesn't work. But I can press F, which is 2B. Yeah? I think this is quite odd that it doesn't work that way, and the keyboard still is marketed, or has been marketed, as a N-key rollover keyboard. At least according to Wikipedia, I'm not entirely sure. And yeah, also the more weird key, for example the pause key, just outputs 8 bytes. These 8 bytes are outputted. So now we can take a look at the code of this application. I need to point out that this code is actually not written by myself, but I took it from this PS2 keyboard library for Arduino, but I couldn't repurpose much more code from this library because it's also optimized for getting keyboard input to the Arduino program if you want to use it, and not actually for my purpose. So it's just this code which I needed, and it works in quite a simple fashion actually. In the setup code I set these pins as input mode and use the internal input pull-up resistors because we have idle high states, and attach my pin 3, which is connected to interrupt 0 to the falling edge. And so every time we receive a falling edge, this method is called and reads in the data from the data pin. Here it looks if the time is, if more than 250 milliseconds have elapsed since the previous call, and if that's the case, we can use this as a new character, because it doesn't take that long to send 1 byte of data. And yeah, here the single bits are set. The value bit which has been read is shifted by n, and n is bit count of bits that have already been received, and then is set via this OR operation in the incoming byte. And if the final bit count has been achieved, so if all the bits have been read, we just add it to this buffer. And the getScanCode method checks if there is an unread byte available in the buffer, and if it is, it will be returned and removed from the buffer. And I do this in the loop and output always if there is one. So the next step has been to also send data to the keyboard, because now I'm only receiving keyboard data from the keyboard. And you can see here under section host commands on this website that if I want to set a status LED, I need to send an ed command, and then I need to wait for the keyboard to respond with an acknowledgement in the form of byte FA, and send the data. Send another byte with bit 0 for scroll lock, bit 1 for numlock, and bit 2 for caps lock. This protocol works like that. First I need to tell the keyboard that I actually want to send data, because it's using the same lines that are used to read the data, also sending data. I need to pull the clock line from idle high state to low state. And I also need to do it with the data line. And after I have pulled the data line low, I can pull clock high again and then release it. So I don't take control over it. I reconfigure it as an input pin and not anymore output, which I did for this red part here. And then from the second falling edge of the clock signal, which is being generated again by the keyboard, I can send my data and also my parity bit. Then here the keyboard does an acknowledgement, which I can ignore, but I can't ignore this, because then the keyboard will tell me that I need to resend if I do this wrong. And I implemented this in another sketch here. The PS2 LED is what I called it, and I will quickly upload it, then I can show you that it actually works. So I now press my caps lock key, and you can see that the keyboard sends an FA also. So here I get the 58. So here I get the 58 signal. I send my ED, which isn't shown here, but I sent it. Then the keyboard says FA, and I send my LED information. Then it says FA again for some reason. It isn't documented on this website, but it says it. And yeah, then I turn it off. I mean, I programmed the LED a little bit wrong, so it's toggled, so it's also turned off as I release the key, which isn't really necessary, but still, I programmed it wrong. I didn't bother to correct it. So here I added a method, send message. So this message sends the data. Here I also specified no interrupts while I configure it, and the IRQ pin, which is a clock pin, is set to output and set to low, and then I wait for 60 microseconds, which appears to be recommended somewhere on this website here. Yeah, here, 60 microseconds, and then I release it. And after that, I pull the data line low and allow interrupts again, and then on the clock signals we are sending bits. So the last bit, the 8th bit, actually is ninth one, bit number 8, because it starts from 0, will be the parity bit. In the ninth one, I reconfigure the pin to be input pull up, which also means that it's pulled high, which I need to do here. And the other ones are set here. So I mask the bit because so I shift my message bit, my message byte. I shifted B, which is the number of the bit that I want to get, and check if the last bit now, or the least significant bit, is set with this AND 1, and this I'm outputting here, and if it's 1, then I'm going to add 1 to set bits, and if 0, 0 is added to set bits, and set bits is used to check whether I need to so it's used to calculate the odd parity bit. This is just a faster version of the modulo operator, modulo 2. Just check if the least significant bit is set to 1. And other than that, this sketch is pretty much the same. Then to the previous one, I just have a little bit of logic for my LED stuff. And yeah, the next part has been to actually send the data which I get into my Arduino to the computer. And therefore I needed to use an Arduino Leonardo because its chip allows to emulate an HID, a human interface device. And this human interface device can act as a keyboard or as a mouse or gamepad or something along those lines. But the HID library isn't really optimized for that purpose, and so I need to modify it a little bit before I could use my code, which I'm going to show you in a bit. And if you want to also do this project for your own, then you need to go to your Arduino folder or your Arduino app. So going to do that, go arduino.app or the Arduino folder under Windows. You show the package contents. Then you're going to through the tree, contents, resources, Java, hardware, Arduino, AVR, cores, Arduino. Then we need to go to file USB API.h, which I still have opened here, and scroll down until you find the keyboard underscore class. And this class has method send report, which originally has been a private method, but I need to use it to send reports to the computer. What a report looks like is defined in this struct, and a report just basically tells the computer the current state of the keyboard. And yeah, a report has 1 byte for the modifiers. You can look into the USB HID specification stuff, and here it will tell you which bit from that byte corresponds to which modifier key. And these are the modifier keys. And then we have a reserved byte, which doesn't actually serve any purpose as far as I'm concerned. It's just put in there for future proofing. And then we have an array of 6 entries for the key codes. And this contains key codes of 6 pressed keys, or up to 6 pressed keys. If no keys pressed, it's obviously 0. And we can find the key codes here. So this is much more simple, much more simple protocol. Just 1 key code corresponds to 1 key, or for example, or the modifier keys. So how does this code look like? Here's the PS2 to USB code. First, we need some key maps, because we need to map the scan codes from PS2 to the scan codes for USB. And Here I have the K array and the extended array for the keycodes. If the keycodes are preceded with an E0, yeah. So this code you know already. Setup codes here. We set up the key maps, and then we call keyboard.begin. This is for the keyboard library from Arduino. But now we can use the send report method here. We've also defined a report, and we are going to send a pointer to that report to the computer, basically. And what we do to populate that report is we use the report add and report remove methods, and they put in one key or remove it. So here it is checked whether it's a modifier key, which, I mean, this site for some reason used numbers from 224 to 231, and I also replicated this, although I don't know why they are as scan codes, because they aren't really sent as scan codes, they are sent as bits in the modifier byte. But anyway, I set the bit, which I shift 1 by difference of k and 224. K is inputted here, and it's calculated with the mappings I showed you here. So, and for the normal keys, I just check if it's already present in the report, and if that's not the case, I add it to the report, and the same goes for the report remove method. Just remove it, and here I add it. Also, I have here code for sending the LEDs. Or if these are the key codes for my the keys that can turn on and off LEDs, and that's why we have them here. Then we can send the message of the LED to the keyboard, send ED again, then we can, yeah, and then if we receive our FA, then we send another message to the keyboard which contains all the LEDs. Yeah, I think that's about it about my project. If you are interested in more details, you can always ask me in the comments, and I will put all my information on my sources and source code into the video description, so that you can use it if you want to make something similar on your own. Of course, you could also use it for gamepads and mice and everything, but you would need to read about their protocols. So yeah, thanks for watching and goodbye.